This is the Calculus Chapter 1 Exam Review number 3. So this problem was taken from the 2008 AP exam for Calculus AB number 4. So here we have a particle that moves along the x-axis so that its velocity at time t for t is between 0 and 6 is given by the graph shown. So this right here is our velocity versus time graph, not the particle moving along the x-axis. Okay, just a quick diagram. Here's our x-axis and our y-axis. There's a particle. Let me get another color. Like this, like this little dot. It's moving left and right, right? So it's going back and forth, or whatever the motion is taking is described by this velocity versus time graph. Okay, the velocity is 0 at time 0, time 3, and time 5. So we know it's going 0 units per time at those 3 points. Okay, and the graph has a local minimum at t is 1. So we know this is a minimum right here. And it has a local maximum at t is 4. So we know this is a max. Okay. What else? The magnitude of the areas of the regions bounded by the t-axis and the graph of v on the intervals of 0 to 3, 3 to 5, and 5 to 8 are 8. So we know the area here is 8. Right, so that's 8 units squared, and we know it's below the x-axis, the t-axis. I'm gonna mix that up, but below the t-axis, between 3 and 5, this is 3 units squared. That's the area, and between 5 and 6, we know the area of this region here is 2. Okay, it's below the t-axis, so that's negative again. So the initial position of the particle is 0. Okay, so again here we know the particle is starting here at the origin, right, where x is 0. And it's only moving left and right on the axis, on the x-axis. And this graph, again, is describing the speed, not where it is on the x-axis, because it doesn't go below, it's always staying on the x-axis. So this is just the speed. Okay, so part A, it says find both the time and the position of the particle when it is farthest to the left. Justify your answer. Okay, so again, if my particle starts at time 0 right in the center, its speed or velocity, right, is negative here. So negative velocity, we know it means in like the left direction. So it's going left for 3 seconds, right? And then it turns around and goes right, has positive velocity for 2 seconds, and then it turns around again and goes left for 1 second. And what is the area measuring here? Well, velocity times time, right? The area is measuring our distance. So this is the area unit squared is really our distance, okay? So we know this is our distance that it's traveling, 8. We know that then it travels 3 and then it travels 2, right? I'm going to write 2 again. So if I were to draw a picture, I know that the particle starts here at 0, right? At x is equal to 0. It travels to the left to 8. So that's at x is negative 8, right? And then it travels to the right 3. So then it goes 1, 2, 3 to the right at x is negative 5. And then it travels back to the left 2 at x is negative 7. So it goes like this, stops here, goes back to negative 5, and then goes to negative 7. So where is it farthest to the left? Well, it's farthest to the left here when it goes to the left 8 units, and that would be after, right before it turns around. So at t is equal to 3, right? At t is equal to 3 seconds, we know our distance is 8 units on the x-axis to the left. 8 units left on the x-axis. Or it's value is -6. X is -6. So that particle is on the x coordinate of -6, 0. All right. So a quick justification would be, well, what are the possible times? Well, it's 0, 3, 5, or 6. And we know that at time is 0, we know that the distance is just 0. It's on the x-axis, right? I can say it's the x value, right? At time is 3, we know it's the x value is -8. When time is 5, we're at -5. We already talked about that here. And then when the time is 6, we're over here at -7. And so again, this is justifying why we have 3 seconds and we're 8 units to the left. Okay, so that's part A. Let's go ahead and do part B. Let's box our answer. Part B says, for how many values of t between 0 and 6 for t is the particle at x is equal to -6? Oh, well, if we look at this graph, right, we start at 0, we go to the left. Well, when we're going to the left to -8, we pass it once, right? So on way to -8, we pass it one time. Pass -6 once. And then we go back to -5. Well, we pass by -6 again. On way to -5, pass -6 again. And then finally we go back to -7. On way to -7, we pass it one more time. So that's 3, this is supposed to look like that, 3 times we pass x is equal to -6 3 times. Okay, and there's the descriptions of when. Finally, we want to look at the interval between 2 and 3. Okay, so between 2 and 3, x is 2 here, x2, time is 2 there, and time is 3 there. So between these 2 points, right, is the speed of the particle increasing or decreasing? And the hint is, speed is the absolute value of velocity, right? It's just the magnitude. We don't care about direction. Well, we know that the velocity is increasing, right? It's going from negative value all the way, it's going toward positive. So the velocity is increasing, but the speed is actually decreasing because the magnitude is getting smaller, right? From over here, we have a big magnitude, even though it's negative, the absolute value is getting smaller and smaller. Okay, so so part C, the absolute value of velocity is getting smaller. So speed is actually decreasing. Okay, so that ends for us the review of Chapter 1, Exam number 3.